All right, when solving these, the first thing you do want to do with that first equation is rearrange them. So the first one, it's how we're normally used to seeing it. We got our x and our y equals our number. The second one, we want to rewrite it so it looks the same way. So I'm going to rewrite it as 3x plus y equals 29. I keep the little bracket next to it because I'm still showing that this is a system of equations. All right, now at this point, we can go ahead and start solving it using elimination, but you'll notice these don't add nicely right now. So we need to multiply one or both of the equations by something so they will add nicely. In other words, so that one of them, either x or y, will add to 0. You have two different ways you could have accomplished this. And I know different people did it different ways. The first way you could do it is you could multiply the first equation by -3. That'd be perfectly fine. That would make the x's cancel out because we're making it so we'll do a -3 plus 3. Alternatively, you could have multiplied the second equation by -2. That'd be setting it up so that the y's would cancel out. You can do it either way. Since I have it written this way at the moment, I'll go ahead and do it this way. But again, they both work. All right, and I've talked about this before, but I'm going to keep talking about it because a lot of us really need the reminder. Rewrite both equations. Even if you're just changing one of them, rewrite both equations. That prevents a lot of possible errors that can crop up along the way. All right, so now there's our new system of equations, the one that we can actually work with very easily. So go ahead and add them together. So x plus a -6x is going to give me -5x. 2y plus a -2y. Notice I still talk that out. I still check it to make sure that's going to give me 0, which it does in this case. And then that equals a -35. Now it's hopefully easy to solve at this point. We divide both sides by -5. X equals a +7. Once we know what x is, of course, we still have to figure out what y is. In order to find out what y is, we plug it in. We plug in the value that we just found. So I'm going to plug it into one of the equations. And again, it doesn't matter which of the two original equations we plug into. But in this case, I think the second one might turn out to be a little easier because I'm going to be looking to solve for y. And there's nothing multiplied by the y. So I think that'll be a little bit easier with the algebra. So I'll plug it into that one. That'll give me y plus 3 times 7. And then that equals 29. So work out the math from there. Subtract the 21 from both sides. You should find that y equals 8. So we get a final answer in this problem of 7, 8. All right, for the second one, you have options about whether you want to have the x's or the y's cancel out. If you want the x's to cancel out, you're going to want to make both of these into a 20 and make one of them positive and one of them negative. If you're going to want the y's to cancel out, both of those go into 21, so I'd make them both into 21. And again, one has to be positive, one has to be negative. Because one always has to be positive, one always has to be negative though, I'm going to choose to deal with the y's because one of them's already positive, one of them's already negative. So I just think that's the slightly easier way to go. I'm less likely to make a sign error along the way. So multiply the top one by 3, second one by 7. And it's not like doing it the other way would be wrong. It's just I think this one's a little simpler, so that's the way I'm choosing to do it on this. All right, so there's my new system. I can go ahead and now add those together. We should get 47x equals 141. Divide both sides by 47, and we get x equals 3. Plug that back in to either one of the original equations. Of course, it doesn't matter which one. So I'm going to plug it in the first one just because I don't really see any difference between them. So I subtract 12 from both sides, and then divide both sides by 7. Should find that y is 1. So our final answer here is going to be 3, 1. So that first one is set up for substitution, so start working through that as you are still working on it yourself. And so when you work through that first one, you should have ended up with a line that looked like this, 13x equals 0. And this is where some people end up looking at their work like, wait, what did I do wrong? But 0 is a number. Just like any other number, I can still divide both sides by 13 here. And 0 divided by 13 is 0. Our x-coordinate is 0 here. That's okay. And then, again, to find y, I plug that into either equation. The second one definitely looks easier to me in this case, because it's already set to be y equals. So I plug the x equals 0 in for that one, find that y equals 9. So there's my final answer. Our coordinates for that first one are 0, 9. All right, and then for this, doing the second one, there's lots of different ways that people approach this one in terms of which variable they choose to eliminate. So far, whenever we've seen a positive and a negative y, we've tended to cancel those out. And that would work here. You could multiply the top one by 3 and the bottom one by 7, and you'd be able to cancel the y's out. But I'm actually not going to do it that way, because that requires multiplying both of them by something different. And I can actually do it by just multiplying one of the equations by something. And if I can do that, I tend to. Again, it's not that one's right or wrong, it's just I think this way is a little easier. If we multiply either one of those equations by negative 1, one of those x's will be a positive 2x, and the other one will be a negative 2x. Doesn't matter which one you multiply. So I'm going to multiply the second one, just because. So 2x minus 7y equals 5, still there. Always writing that down as well. Then, multiplying the second one by negative 1 is having this effect of flipping the sign of everything. Having done that, we now can go ahead and add them together. And notice 2x plus the negative 2x, that gives us 0. That's what we wanted. So we end up with negative 10y equals negative 10. Divide both sides by negative 10, y equals 1. Plug it back into either one of the original equations. Again, it doesn't matter which one you plug it into. So they look about the same to me here. I'll plug it into the first one then, just because I tend to default to the first one. So I'm going to add 7 to both sides, and then I'm going to divide both sides by 2. I find that x is 6, so my final answer here is going to be at 6, 1.